Welcome back to the class. We will continue the chapter carbon and its compound. Why it is carbon compound? The other name of carbon compound is organic compound because it is made up of only carbon, that is living product, byproduct of living organism. Okay. Now we see some structures. Structure of oxygen first. Oxygen having atomic number, what is that? 8. And 8, atomic number is 8 means proton also 8, electron also 8, electronic configuration, what is that? First cell 2, then second cell 6. The last cell electron is called valence cell electron. This cell name is K, second cell name is N. This cell electron is called valence electron. To draw the dot structure, we use this electron, valence electron. Okay. Is it stable? Is it attained octet rule? Octet means 8 electrons should be there. Is it follow? No. It does not follow this octet rule. So it undergoes reaction to attain stability. Stability means to follow octet rule, 8 electrons. What they do? 2 oxygen molecule means O2, isn't it? This now you are going to draw the dot structure. Oxygen. Okay, oxygen outermost. Now you draw the structure, dot structure we see later. Oxygen, okay, oxygen atomic number is 2, 8, 6. First cell 2 is there, second cell 6. And another oxygen, nucleus is in the middle, first cell 2 electron, second cell 6 electrons. Both are not stable because outermost only 6 electrons are there. So they go for sharing of electrons. Okay. So how do they share? I will show you again. I told you if it needs 2 more electrons. No? So among the 6 electrons, you write the 2 dot here, 2 electrons here, and remaining 4 are there. 1, 2, 3, 4. So this oxygen has 6 electrons, and another oxygen has 2, 6, 2, 6. Okay, this oxygen has first cell 2, second cell 6. No? So you draw that, you show the last cell electron. 6. Among these 6, you write the 2 here, 3, 4, 5, 6. Like that. So this oxygen also 1, 2, 3, 4, 5, 6. This oxygen electron also 1, 2, 3, 4, 5, 6. Clear? Now they go for sharing. Understand? To attain stability. So look at this oxygen fully. How many electrons? 1, 2, 3, 4, 5, 6, 7, 8. Attain octet rule. Now it follows octet rule. Look at this oxygen. This full circle you see. 1, 2, 3, 4, 5, 6, 7, 8. Octet rule. Both follows octet rule. Okay. So O2 is a stable compound. Sorry, stable element. Same kind of element. Atom is, it is called element. Understood? So what type of bond? Double bond. Okay, each bond contains 2 electrons. Now what is the covalency of this oxygen? What is covalency? Number of electrons shared by one atom. So this oxygen share its own 2 electrons. So covalency of this oxygen is 2, and this oxygen also 2 electron undergoes sharing. Its 2 electrons undergo sharing. So covalency of oxygen is 2. Number of bonds formed is 2 bonds. Each bond contains 2 electrons, and unshared pair of electron, here 1, here 1. Here this is lone pair. 2 electrons are called lone pair. And how many lone pairs are there? 2 lone pairs. Here also 2 lone pairs. What is lone pairs? Unshared pair of electron, not bound for sharing. It does not involve in sharing of electrons between the atom. Clear? Now let us see carbon dioxide. Carbon dioxide, isn't it? Carbon is a central atom. Oxygen is, you write both the oxygen and both the side of the carbon. Each carbon, first you should know symbol and what is that? Sometimes they will give in word form, carbon dioxide. So know the symbol and atomic number is important. For chemical reaction, atomic number is important. For example, carbon ka atomic number is 6, oxygen ka 8. Okay, 2, 4 electronic configuration, 2, 6. Clear? First cell 2 electron only maximum they can accommodate around the nucleus. Second cell remaining up to 8 can be. Okay. So listen, both are not stable, so both go for reaction. It did not follow. It is not following the octet rule. So now mention the 4 electron. Carbon 1, 2, 3, 4. And oxygen has 6 electron. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Only when you go for, this is called dot structure. When you go for drawing the dot structure, only you see the valence electron. Only you show the valence electron. Because they only involve in chemical reaction, sharing or transferring the electron. Chemical reaction only these electron undergoes. So mention those electron, okay? Don't add this. Only last cell electron you write. Clear? Now these two share. Okay? Understand? Now carbon attain octet. See? Look at the carbon. Count the carbon electron. 1, 2, 3, 4, 5, 6, 7, 8. And look at the oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Look at this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Each one of them attain octet rule. Okay, this is a bond or loose dot structure of which compound? Carbon dioxide. Can you draw? First you should draw the symbol with atomic number and electronic configuration. Show the outermost electron around the atom, particular atom. Next one is, note it down all. Next one is S8 sulfurate. For drawing the structure, you can have two structure in sulfur. Okay, allotropes are there. The rhombic and white sulfur, different type of sulfur is there, rhombic sulfur and all. So one is circular form, one is crown form. See here, one is this circular form, the other one is like this, crown form. Okay, we are going to see both the structure. Two are allotropes of carbon. Okay, only structure varies. Now, for making a circle sulfurate, sulfur is a molecule of element because same kind of sulfur atom. 8 sulfur atom together form a free state of sulfur. Understand? So first, 2, 3, 4, 5, 6. So 5, 6, 7, 8 structure. Okay, 8 structure or 8 number of sulfur atom. And you know I told you symbol right, and its now atomic number is electronic configuration 286. So what is the 16? Atomic number is 16. Its atomic number is 16. 2 comma first cell 2 electron, then second cell 8, remaining 6 is left. 6 electrons are left. You write in the last cell. Now you mention only the last cell electron because dot structure we are going to draw now. Dot structure. Okay, Lewis dot structure. Understand? So you got to mention this. Only outermost electrons. Sulfur outermost electron is 6. So you do one thing. 1, 2, 3, 4, 5, 6. Understand? 1, 2, 3, 4, 5, 6. 6 electrons should be there each sulfur, around each sulfur atom. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? 5, 6. Now what they do? Each sulfur need 2 electron to stable, no? Because 6 is there means more 2 electron to attain octet. To get 8 electron, it needs 2 more electron, isn't it? So here one sulfur, here one sulfur. They will share. So this sulfur, how many electron now? 8 electron. Look at this 1, 2, 3, 4, 5, 6, 7, 8. Clear? Now look at this sulfur. 1, 2, 3, 4, 5, 6, 7, 8. 2 bonds. Each sulfur form 2 bonds. Each sulfur form 2 bonds. Clear? Next. Here. These sulfur form 2 bonds. And how do you draw? 1, 2, 3, 4, 5, 6, 7, 8. Clear? Between the sulfur, 1 bond. Between two sulfur. How will you draw this one? Count it, you will get 8. Okay? Sorry to come here. Okay, like that you draw accordingly. And as I like the structure, like a circle. This is not proper, you draw properly, okay? This is a one structure of sulfur 8. A round structure. Okay? Next structure is crown structure of sulfur. What is that? Crown structure of sulfur. Okay, first you draw W symbol. Okay, then you draw here one line, then center one line. Joint. Okay, then you draw sulfur. Each corner sulfur. Okay, clear? And I told you sulfur, around the sulfur 6 electrons are there. 1, 2, 3, 4, here 5, here 6. Five, 6. Clear? 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. Getting? Like that each carbon you to draw, each sulfur you to draw. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2. Okay, bond you make it 1 electron. The rest you draw like this. This is called lone pair. Okay, 2 lone pairs are there. Here also each electron you draw. Now understood? This is a Lewis. Then you rub this slowly. Okay. This is a dot structure of which one? Which molecule? Sulfur molecule. Can you draw both the structure? Let us move to next. Allotropes of carbon. This allotropes of carbon we have studied in the previous class. Carbon can exist in different form. See, diamond is made up of only carbon. Coal is made up of only carbon element. Graphite is made up of only carbon element. And fluorine is made up of only carbon. But if you look at the structure, diamond is pure white, whereas coal, graphite different color, dark in color. Why? Because of structure. Because of bonding. Okay, they are made up of only one element, that is carbon, pure form. But why the color varies, structure varies, properties varies? Because of their structure formation, bond formation. See here, allotrope of carbon, diamond, graphite, okay, and carbon tube, fluorine, carbon 60. It is made up of only carbon, that is fluorine is made up of only carbon. 60 number of, how many number of carbon? 60. Okay, they look like a football, dome like structure. Okay. And a pentagon, it is made up of hexagonal structure and a pentagonal also. As a structure. Okay, different structure. It is made up of only carbon. How many number of carbon joined? 60 number of carbon joined to form a ball like structure. That is called Buckminster fluorine. And diamond, you know, diamond, it is the purest form of diamond is white in color. You can say colorless also, white in color, pure form of hardest substance. It is made of only carbon. Look at the structure, they are very shiny. Whereas carbon tube, they are just not that much shiny. Properties are varies. And this carbon, that is what allotropy definition. What is the definition? Carbon can exist in different forms. And in which, what are the properties varies? Physical properties varies, but their chemical properties are alike. Their chemical properties same. Their chemical properties are same. All are carbon, all react with oxygen to form carbon dioxide. There the carbon reacted with oxygen, carbon dioxide. Here also carbon dioxide burning, combustion. Combustion of this compound gives carbon dioxide. Chemical properties same, whereas physical properties varies. They are shiny, they are little shiny, they are not shiny appearance. They are very hard, hardest substance. It is not as hard as diamond. They are not as hard as diamond. Okay. And then next what is that? It is easily breakable. We can break it. Brittle we can say. And this physical density, hardness, melting point, boiling point. These are all varied in this compounds. These all properties are varied in this compound. Only chemical properties are similar. All chemical properties are similar. This is the allotropes of carbon. Next one is unique nature of carbon. See, carbon has unique nature. That's why we are having separate study, carbon compound, organic chemistry. When you go for higher, you will have separate chemistry, that is organic chemistry. Why is it separated? Because of their unique property, their peculiar property, separate property. They are separate from others. They are different from others, carbon compounds. Why? Carbon have unique nature like catenation, tetravalency formation, etc. In this world, carbon, more than 3 million compounds are there in carbon compound. In carbon chemistry, organic chemistry, more than 3 million compounds are there made by carbon. They are having different property. Understood? That's what they have a separate study called organic chemistry or organic study. More than 3 million compounds are there because of their unique property. Now let us see what is unique property. First one is catenation. What is catenation? Catenation means self-linking of carbon. Carbon link with another carbon. Carbon make a bond with another carbon. Carbon make a bond with another carbon. Again another carbon. Like the million of carbon, they can make such a way, they can form straight chain or branch chain. Okay, they have the ability to form such a long chain. More than 30, 40, 50 carbon can have. Okay, and then they can have the ability to form a cyclic compound. Straight chain can form. Okay, and cyclic form can form. Cyclic compound. Okay. Like this cyclic compound they can form. So such a property only carbon has. And beside this silicon more than like only 7 bonds they can make. Silicon can form up to 7. Carbon can have more than 30, 40 carbon, 100, more than 100. Such a big molecules they can have. They will link one another, self-linking. Self-linking means carbon linked with another carbon. Okay, such a type of property who has? Carbon has. That's what there are millions of compounds existing in this world. Organic compounds. So this property is called catenation. What is catenation? Self-linking of carbon with another carbon to form long chain of carbon or branched chain of carbon or cyclic chain of carbon, cyclic form of carbon. This property of carbon is called catenation. Okay, what is catenation? Self-linking of carbon with another carbon to form a long chain or branch chain or a cyclic compound. This property of carbon is called catenation. Only carbon has such property. That's what it is called unique nature of carbon. Understood? The next property is tetravalency. You know carbon atomic number is 6, 2, 4 electronic configuration. So outermost 4 electrons, so make a 4 electrons, dot structure you make it. So they can have a how many bonds with another hydrogen? 4 more electron required to attain stability or to follow octet rule. They need 4 more electron. So they get electron from 4 hydrogen. Understood? So how many bonds? 4 bonds it forms. Sharing its 4 electron, they will form a 4 bond with another atom. Here 4 bond with hydrogen. Such a property is called tetravalency. Because carbon can form 4 bonds by sharing its 4 electron with other atom. Clear? That is called tetravalency. It is somewhat unique property of carbon. Next one is stable compound. They are almost stable. The bond formed by carbon is almost stable. Why is it stable? Reason is there. Carbon has 6 electrons and it has only 2 cells. So size is almost small. So it is nucleus, first cell and second cell. Size of the carbon is small. Okay. Size of carbon is small. If they make bond with another atom or bond with what is a hydrogen, you write. Bond with the hydrogen. They are making bond with the hydrogen. 4 hydrogen it is making. Because it needs 4 more electron, no? This central atom, there is a nuclear charge. If atom has 6 electron, they have 6 proton at the center. 6 positive charge at the center. That is called nuclear charge. Around the nucleus, there are electrons are there. Negative charge. 6 negative charge. And inside the nucleus, 6 positive charge. That's a neutral atom we have drawn. They are neutral. Plus and minus equal. Number of plus electron, plus charge, minus charge remain same. This plus 6 plus charge attract the electrons. Since it is small size, they have the strong ability to attract the shared pair of electron towards itself. It is attracting, it is sharing the electron with hydrogen, isn't it? Carbon is at the center. Carbon is at the center, isn't it? With the 4 electron, it needs 4 more electron. So it make a bond with 4 hydrogen. Because each hydrogen has 1 electron. So the central carbon has 6 positive charge. This positive charge attract the shared pair of electrons towards itself. Why more power of attraction? The magnitude of attraction is strong. Why? Because size is so small. If it is big size, nuclear charge is middle. If it is big size, they cannot hold the electrons strongly. It is small size, so nucleus is at the center. Easily it can hold. It can hold those shared pair of electrons towards itself. So they form a strong bond. They hold very strongly. Central nuclear charge is holding the electron, attracting the electron very strongly because of small size. If it is big size, the outermost cell electron shares, isn't it? Nuclear charge is here, the size is big, the attraction is not that power as carbon has. The attraction, nuclear charge attraction is not as power as carbon. Because big size attraction is less. Small size of carbon attraction is very strong. So nuclear charge hold the electron, hold the shared pair of electron towards itself. So they form a strong, stable compound. Carbon can have a strong, stable compound because of small size. Clear? That's all. Read the topic. Doubt question you write in my WhatsApp. What are the questions? I will clear in the next class. Okay? Thank you.